When designing large-scale distributed systems, choosing the right communication pattern is critical. This choice directly impacts scalability, performance, and the overall user experience. And while modern tools like message queues and gRPC are powerful, classic HTTP-based paradigms remain the bedrock of most architectures. In this video, we'll master 5 of them so you can architect systems like a principal engineer. First, let's talk about REST, Representational State Transfer. It's an architectural style where resources are accessed through a standardized, stateless interface. It uses the existing HTTP methods like GET, POST, and DELETE, making it incredibly intuitive. A client sends a request. The server processes it and sends back a response, and then the connection is typically closed or reused. This request-response cycle is its core characteristic, perfect for most standard API interactions. But what if you need continuous, two-way communication? That's where WebSockets excel. Unlike REST, a WebSocket establishes a persistent connection over a single TCP channel. After an initial HTTP handshake to upgrade the connection, it becomes a full duplex pipeline. This means both client and server can send data anytime, independently. It's purpose-built for low-latency, real-time apps like chat, collaborative tools, or financial trading platforms. Now let's consider server-initiated communication with webhooks. A webhook is a unidirectional, server-to-server pattern. Think of it as a callback. When a specific event happens on a source server, like a payment completing in Stripe, it sends an event-driven push notification via an HTTP POST request to a public endpoint you provide. This architecture is asynchronous and highly efficient, eliminating the need for inefficient client polling. For one-way streaming, server-sent events, or SSE, provide an elegant solution. It allows a server to push one-way updates to a client over a single connection. The client initiates the connection, and then the server continuously streams data, like news headlines, stock prices, or social media feed updates. It's incredibly lightweight because it's built on standard long-lived HTTP, making it simpler than WebSockets when you don't need data flowing from the client back to the server. Finally, for real-time video or audio, there's WebRTC. It enables direct peer-to-peer communication right inside the browser. Here's how it works. A central signaling server, using WebSockets or HTTP, helps two clients exchange metadata to discover each other. Once that handshake is complete, the audio and video data flows directly, reducing server load and minimizing latency. This is the technology powering applications like Google Meet and Zoom. In any high-level design discussion, remember that these patterns are not mutually exclusive. In fact, a real-world system is a hybrid, using multiple patterns simultaneously. An e-commerce site might use REST for its product catalog, WebSockets for live support chat, webhooks for payment notifications, and SSE for stock updates. Knowing when to use each one is what defines a strong architecture. It's about choosing the right tool for the right job. So, to recap, let's crystallize the key use cases. Use REST for stateless APIs. Choose WebSockets for bidirectional interaction like chat. Implement webhooks for server-to-server events. Leverage SSE for one-way streams like news feeds. And for direct, low-latency media, WebRTC is your answer. Understanding these trade-offs and applications is fundamental to designing robust, scalable systems.